All right, we're going to continue on with angles in the circle, kind of picking up on what we left off on the past couple of days. We've got a couple of different types of angles in circles. The first one we'll talk about is central angles, and that's any angle that stems from the center of the circle. Basically, the center has to be your vertex. We talked about the fact that in a central angle, if you've got an arc measurement, I don't know if you can really see that, it's green here. The central angle always equals the arc measurement. So if the arc is 80, the central angle is also 80. Those are always congruent. And we also talked about inscribed angles. Those are angles that are on the circle. So the vertex stems from some place on the actual circle itself. And those are always going to be half your arc measure. So if your arc was 80, that one's not going to be 80, it's actually going to be 40. The inscribed arc is always half the arc measure. All right, so we've got two other ones that we're going to talk about. The first one's exterior angles. Exterior angles. Those are basically angles that are formed outside the circle. A good little picture of this would be if any two lines cross. These could be secant lines, tangent lines, any combination of the two, and they cross outside. We're looking at this angle here. That's an exterior angle. Now we also have interior angles. And interior angles, obviously, is what it sounds like. It's two angles that are made when lines intersect within a circle. So if you've got two chords that are crossing through, you've got some vertical angles that are made right here and here. Kind of looks like a cool little half ninja. Alright, so let's take care of one of the first theorems with these. Now, the first theorem just states that if you have a tangent line and a secant line, so if a tangent and a secant, and remember when we're talking about secants, we're really kind of talking about chords. So if you've got a tangent line and a chord, and those two things intersect at a point on the circle, intersect at a point on the circle, then the measure of each angle formed is 1/2 its intercepted arc. These theorems will make a lot more sense once we have some diagrams that will kind of help with the explanation process. So we'll go ahead and draw out a circle here. And we'll throw a tangent line in yellow here. And also a secant line coming off of that. Then orange, looks like a chord. That's what we're looking for. So now we're talking about this angle here. The angle that's made, we'll call it angle 1. That's always going to be half of arc x. So angle 1 equals half of x. And you also can have angle 2 over here. And that angle is just going to be obviously 1/2 that arc length y. So a measure of angle 2 is 1/2 of y. I'll do 2 examples with these theorems today. Hopefully really kind of hammer the point home. Real quick examples here. Let's make the circle so you can actually see it. Ooh, too big. Alright, let's move that over. Let's throw a tangent line down. And we will also throw a secant line off of that somewhere. Let's just make a line here. Call that angle 1. We don't know what angle it is. Angle 1. Now I'm going to tell you guys that that arc outside is 112 degrees. Find angle 1. Well, angle 1 is just half of that. So it's 56 degrees. Easy enough. Now let's get rid of that. Throw another one down. I'm going to throw another tangent line, kind of tangent, looks somewhat, right? And a secant. This time around, I'm going to tell you guys that the angle made is 118 degrees. You guys have to find x and y, both of them. X should be pretty easy. That's the arc that it intercepts, so it's just going to be twice the length, which means it's 236. I think the math is right there. Now for y, you got a couple of different options. You could say, well, if that's 118, I could find the supplementary angle and find y that way. Or you could say the full circle is 360, subtract 236 from it. Either way you do it, you're going to get y equals 124 degrees. I think those ones are pretty easy. We're going to go on to another theorem now. Little trickier, just because it's a little bit more math with it. And the theorem is going to deal with interior angles this time around. So if two chords intersect in the interior of a circle, basically any two secant lines that intersect inside a circle, then the, oops, let's make that so you can read it, sorry. On the interior of a circle, then the measures of each angle is 1/2 the sum of the measures of the arcs intercepted by the angle and the vertical angle. Sounds like kind of a weird thing there, but if you kind of visualize what we're talking about, it'll make a little bit more sense. So it's 1/2 the sum of the arcs intercepted by the actual angle and its vertical angle. Now this one's definitely going to be a lot easier using a diagram. I'm going to scroll down a little bit here. Oh, too far. There you go. If we've got a circle, and we'll throw a couple of chords down that intersect within. I know I can't help looking at that without seeing like a little ninja there. But we'll throw some points on it. We'll say circle F. We got point A, point B, point C, point D, and point E. And the only reason I put circle F there is to realize that those don't cross at the center. We know those two angles are going to be congruent. They're vertical angles. So I'm going to say the measure of angle ACB, that one in purple, it's going to equal the other one. Measure of angle DCE, and we know that because they're vertical. Now what the measure of those are, we said it's 1/2 the sum of the arcs. So if I added those arcs together and took 1/2 of it, that's going to equal those angles. So it's 1/2 the measure of arc AB plus arc DE. Whatever I calculate that to be, that'll be those two inside vertical angles. Let's do an example. It's going to kind of, again, hit it home pretty hard. So we'll throw a circle out here, have a couple of lines cross. And I'll tell you guys that that's 55 degrees. This is 107 degrees. I need you guys to find x. Now we know x is going to be vertical to the other side, so they're congruent. So we're going to use that idea of x equals 1/2 the two arcs that are formed by the vertical angles. So it's going to be 1/2 of 55 plus 107, the other arc. 55 plus 107. Do the math on that real quick. We get x equals 81 degrees. Pretty easy. We could also throw these a slightly different way, make them a little tougher, and if we do that, we'll give you the vertical angle and one of the arcs. You got to find the other arc. So what I mean is if I gave you that that's 92 degrees and this inside one here is 71 degrees, find x, find the actual arc measure. It's not going to be too bad. We know those are vertical angles, so we can go ahead and use that same idea that we were talking about before, is that those inside ones are half if we add up the two arcs. So we'll just kind of write that out in the formula. 71 equals, so the inside parts equal 1/2 92 plus x. 1/2 92 plus x. It's a basic equation. We can solve that. Let's multiply both sides by 2. I get 142 equals, it cancels out the 1/2, 92 plus x. We'll subtract 92, I get x equals 50. So that other arc out there was 50 degrees. So it's the both ways how you can actually use that type of problem. All right, and our last theorem that we're going to cover with this stuff is that we're dealing with exterior angles now. Okay, so the angles outside. And we got a couple of different combos for this. So we can say if a tangent and a secant, or you could have two tangent lines, or you could even have two secant lines. Basically any combination of lines that revolve around a circle. If it's a tangent and a secant, two tangents or two secants, and they intersect on the exterior of a circle, so basically like outside the circle, any two lines that intersect on the exterior of the circle, the measure of those angles, this is a slightly harder one here, just the wording of it. Then the measure of those angles formed is angles formed is 1/2 the difference, and difference means subtraction. The last one was sum, this one's difference. It's 1/2 the difference of the measures of the intercepted arcs. Alright, let's get a good visual here of this one. So if I give you this big circle here, and we'll throw a couple of lines down that cross outside the circle. Let's make that slightly different here. Alright, there we go. Those two lines meet out there at that point. We'll call it point A. So that is B. This could be C. You guessed it, D. And you'd never believe it, E. Alright, if I was looking for the measure of angle CAD, really we're talking about that angle right there. The measure of CAD, it's an exterior one, it's going to be 1/2 the difference of the two arcs. So it's 1/2 CD, arc CD, because it intercepts that arc, minus arc BE. Running out of a little room there. Sorry, guys. So again, if I am looking for that angle A, it's going to be 1/2 the difference of those two. Let's do an example, make it a little easier for us. I think it's a lot easier once we throw numbers in most of these problems anyways, to kind of get a good visual of what's going on with it. Alright, we'll connect those out there. Let's go ahead and call that X. It's going to be our goal. We're going to solve for it. I'm going to tell you guys that arc is 29 and this arc is 93. Solve for X. Well, it's an exterior one, so it's going to be 1/2 the difference of the two arcs. So it's just 1/2 of 93 minus 29. And then you always do the big one minus the small one in these, just so you end up with a positive number. So you're going to find out that X equals 32. That was a 93. Sorry if the red didn't show up. We'll rewrite that. All right, one last one here. The other way you might see these problems written out is if let's do 2 tangent lines on this one. Maybe we'll give you that angle. We'll say it's 59 degrees. We'll be looking for one of the arcs. We'll call that x, and we'll call that last one 168. So now this time around, we're going to use the same idea because we have an exterior angle, but we're just looking for the arc now. So 59 is really 1/2 the difference of those. So we're just going to fill that in the equation. 59 equals 1/2 the difference. Let's take 168, subtract x from it. Solve that out. We'll multiply each side by 2. You get 118 equals 168 minus x. The algebra on that's going to leave us with x equals 50 degrees. All right. Now be careful too, you guys. Maybe we'll throw some central angles in there to try to find some stuff, but everything revolves around the same idea. So at this point, you guys should be able to complete anything in that packet. The whole thing is not due tomorrow, but go ahead and get a very good start on it. That packet will be due Monday. So whatever you guys don't finish today and or tomorrow in class, everything will be due Monday. All right, cheers.